In this video, you're going to learn the concept of the protocol. So this is going to be a very interesting video as well, because this is what most software developers or students would like to know about the programming, the ISO15693 tags. Now, some of the important concept here is what is mentioned here. The VCD talks first. This concept applies to more or less any the RFID or any standard. So it is always the VCD or the reader initiates the talk. So a tag cannot start communicating by itself. So that's the first thing. And also it is also very obvious because the most tags or the passive tags, they do not have the power. So they are powered by the reader writer, and after that the reader writer will start the initial talk. Now the protocol defines what is the request going from VCD to the WIC and what's the response you get from WIC to VCD. So here, and like in any other protocol, we're going to discuss about the frame. Everything is inside a frame, and the frame has got delimiters. It has got the start of the frame, end of the frame, and in between you got all the parameters or the commands and so on and so forth. So if you want to write the diagram of this protocol frame, you will have the start of the frame, the end of the frame, and everything is in between these two delimiters. So the first is the request frame. Every request frame consists of the flags, the command code, and if this command, if it has got any parameters, so that follows. And sometimes the parameters are mandatory and sometimes the parameters are optional. It has got some application data, and this is something like an additional data that is passed along with the command, and the CRC. And here keep in mind, and these two are within the start of the frame and the end of the frame. So this is the structure of the request frame. And the response frame also has got the flags. It has got some mandatory or optional information. It has got the application data fields, and it has got the CRC. If you want to just have an example of this request frame, say for example reading a memory. So in the read memory, the command code will have the command for the read. The parameters will be the number of the block, and the application data could be nothing, but the CRC is always present. So keep in mind, every request and every response frame will always have the CRC, and this is a 16-byte value which you're going to see now in the later part of the videos. So likewise, if the command is a write block command, you'll end up having the command code for the write. You can have the address, the block address, and this is going to be the data, say 4 bytes or a 32 bytes. This depends on what type of tag we are using. Similarly, the response will have, say for example, if you are trying to read the memory blocks, the response will have, this could be nothing, and probably this could be the 4 bytes of data reading. If it's a write operation, the response can have, this could be just like a success, saying that the write is successful, and this could be nothing. And however, the CRC is always present. So here, as usual, when the byte of data is transmitted, the least significant bit is transferred first, and if you are transmitting 4 bytes of data, the lowest byte of the LSB is transmitted first. And also here, the way the flag works is, the flag, as the name implies, it is just a bit value. And here, if you go back to this the commands, so if the flag, more or less the flag controls the optional value here. So if the flag is set to 1, you will have a byte of data in the optional part of this request. So the flag is a 8-bit value. So if all the 8 bits are set, you will have 8 additional bytes in the mandatory and optional parameter section. So likewise, the flag in the response also behave in a similar way. If the flag has a bit 1, the response will have an additional byte here that corresponds to this flag. So you should know about the modes. This is very much used in most of the commands. There are 2 modes of operation. One is called address mode. The other one is called as a non-address mode. So as the name implies, in address mode, the command is sent to a very specific WIC. The only way to identify a specific WIC is by knowing the UID. Now, if a command from a VCD, if it targets a specific WIC or a specific UID, we say that the command is in the address mode. And if a command reaches all the WICs near the VCD, then we say that that command is transferred in a non-address mode. So again, this is all the theory. Probably now when we start looking at the various tags, you will come across these terminologies again. So there is one more way of sending the command to a specific tag, that is called as a selected mode. So here the way it works is, assume that there are say 3 tags near the VCD. So you got a VCD and 3 tags. Now one of this tag can be set as a selected tag. So at any given point of time, only one tag can be in a selected state. So in that case, the VCD can send the command to a tag that's in a selected state. So in this mode also, the command is targeted to a very specific tag. So here, we are not using, or the VCD is not using the UID in order to identify, in order to select a tag. It's just the tag that is in the selected state. The next is the request format. We have seen this, and this is the cleanest explanation about the request command here. Now every command will follow this structure. You have the start of the frame, you have the flags, you have the command code, you have got the parameters, and this parameters depends on the command code, and also the flags. You have got some data, you got some the CRC, and the end of the frame. The next thing is about explaining about what are these flags. So there are 8 bits in the flag, and each bit gives some additional information. Say for example, in this table, the bit 0, the lowest bit, so informs or specifies whether to, it's called a subcarrier flag. This is something you have to be aware of. It says if it's 0, you're telling the WIC to use a single subcarrier frequency. If it's 1, you're telling a 2 subcarrier frequency. And what I know so far is, because this is something, it's not, I would consider this as a bit of a electronics. Probably if I have to use the information, probably I'll speak to one of my colleagues who are good in electronics. Now from the developer's point of view, this is a very easy concept, because some of the commands, they tell us they tell that the command works only when the subcarrier is set to single. So I think this is something to do, with the speed. Okay, this is basically the VCD is telling the WIC so how to respond, whether to use a single carrier or a two carrier. The next bit is about telling the WIC how to transfer the data. Keep in mind all these flags are sent to WIC, and the WIC will decide what to do after seeing this flag. So here the data rate flag tells the WIC whether to use a low rate or a high transfer rate. The inventory flag, so this is this tells whether the command is inventory command. This will understand better when we start looking at the inventory flag. And the next is the protocol extension flag, which indicates whether to use extended format or not. I think most of the tags they don't support, so this will be by default 0. The inventory flag decides the meaning of the bit 5 to 8. That's what is mentioned here. And you can see here the subcarrier and the data rate, it refers to the WIC to VCD communications, not the VCD to WIC. Now when the inventory flag is not set, now the bit 5, 6, 7, 8 indicates the select flag. You remember we discussed about the select mode, where the command is sent to a tag that's in selector state. So that's happening because of this bit. We also discussed about the addressed mode and non-addressed mode. If you want to transfer a command in address mode, you set this bit to 1, otherwise set this bit to 0. And the option flag, this again tells whether you want some optional data from the WIC. Again, you'll be clear when you start seeing some of the examples. So if the inventory flag is set to 1, these bits will give a different information. So inventory command is basically, as the name says, it is basically used by the VCD to identify all the tags in its field, or VCD is trying to build a inventory of all the tags that are near or that are within the field. Now bit 5 tells whether the selection of the tag or selection of the WIC should based on the AFI. That we have seen some WIC supports AFI and or not. And the next bit tells this is something to do with anti-collision. This is a very interesting concept here. We're going to discuss later soon. And here this tells whether to use a 1 slot or 16 slot. If you have read a little bit of ISO 15493 type B, you'll have an idea about this slot. The next is the option flag. This flag was also present when the inventory flag is not set. This is basically, it's part of the protocol. The VCD is telling the WIC. Okay, the WIC understands if the option flag is 1, it will return some more information to the VCD. The next is the response format. Is again one of the nicest diagram you got here. So any response from the WIC will have the start of the frame, the flags, the parameters, the data, CRC and EOF. In most reader writers, you don't see the value of the start of the frame and the end of the frame. So probably these two are followed by the VCD, and what is give to the application is just these bytes. The response flag the response flag is very, very simple. It just has got 1 bit. So the flag tells whether if there's an error or everything is fine, and all other bits or remaining 7 bits are set to zeros. So here again, it says whether the response uses a extended format or not, and most of the time what I've seen is this is just a 0. And the important thing here is when you get a response, the flag is always present. You have to check the value of the bit 1. So you have to get used to this bit 1. In some documentation they refer this as a bit 0. So this says whether the command was executed successfully or there was an error. And if there is, and also there is a clear information about the response error code. And not all error code are supported by the WIC. These are some of the example error code, and it's clearly mentioned here. Say for example, take the error code 10. It says the specified block is not available. So what does that mean? Assume that the VCD, assume that we have got a tag which has got a maximum of 27 blocks. So if the VCD makes a request to a block number 30, obviously the WIC will return an error, and it would probably set the value of the error code to 10. Again, not all WIC supports all the response code, and sometimes you get a very generic error code 0f. Now from the development point of view, so anything which is not 0 indicates it's an error. If we have seen the diagram of this the states of ISO15693, okay, you have seen the states like ideal state. The next is it's going to be like the anti-collision ready state. After that, ready state 2. After that, the authenticated state. After that, it goes to the halt state, something like that. Even this ISO, this technology or this standard also defines a couple of tags. So this is the first power off state, the ready state, the quiet state, and selected state. Again, the documentation says the selected state is optional, so this depends on the manufacturer and the tag as well. Now there is some nice explanation here as well. If you so you have to know this thing in order to do programming. So here, now this is the diagram. Let me get to, so this is the state diagram. So here, as when there is no power to the WIC, it is in a power off state. Like say for example, you have got a WIC in your pocket, so that's in a power off state. As soon as it enters the magnetic field of the reader, the WIC will reach the ready state, and in the ready state, it's already ready to process the commands. Unlike the ISO15693, a lot of you have to do the activation and anti-collision thing, but here you can send some commands while the tag is ready state. So you can get from ready to the quiet state. So the quiet state, basically now, as the name implies, so this tag is something like it's in an activated state. You can send some commands while the tag is in the quiet state, but not every command. You can also move from ready to the selected state. Now we have seen what's the selected state. Again, it tells you whether you can, from quiet you can go to selected state, or from selected go to the quiet state, or when you remove the power, it goes to back to the power off state. Okay, so there is some nice explanation here. Probably you don't have to memorize all these states. Just okay, you will get used to this when you start working on the actual tags. The next bit is the anti-collision bit. Now I'm not going to discuss this in this video, probably because this concept itself needs its own video. Now sometimes you don't have to worry about anti-collision at all. So if you are a student practicing this in your lab, so you'll be given just a single tag. Now while you have a single tag, there will not be any collision from the other tags. So this concept anti-collision is required only when you have got more than one tags and you want to select one of them. So otherwise, think about what's going to happen when all the three tags start communicating. So there will be a collision. So you want only one of the tag to be selected, and you want all other tags to be in a quiet state. Now, so that's what anti-collision means. Now this is something different compared with the way anti-collision works in the ISO15443 or ISO15443 type B, and it is it is simple, but initially when you read it looks like it's confusing. However, it will be easier. So I have to read this couple of times and have to see a couple of other tags to understand how the anti-collision works. So I'm going to explain this in my later videos. The next section is it's still more interesting. This is about the commands. Now this is exactly what a developer is looking for. So what are the commands used to communicate with the WIC? And here the commands are classified into 4 sets. And keep in mind, we are just going through the standard, but the number of commands available in a specific tag like a TA tags or NXP tags may be different. So here the mandatory commands will have the command code from 01 to 1F, and it says any command that are mentioned mandatory in this standard document that are always supported by the WIC. The standard also specifies the optional commands with the command code hex 20 to 9F, and these commands, as the name implies, optional, and some tags might implement some of this or might not implement at all. So the next is about the custom tags. Now custom commands. These commands are invented by the manufacturer itself. Now again, it's very obvious the standard cannot describe the custom commands, but there is some interesting concept that are used here. Every custom command will carry the manufacturer IC code. Now this makes very interesting, and this also prevents two tags from two different manufacturers having the same custom command or a conflicting custom command. We're going to see a few examples on and this, and most tag documents here they have got more information about the custom commands. The other is called as a proprietary command, which as the paragraph says here, it's used only for internal purpose, for testing, and they may not be available in the actual tag. And these are the command codes. Now from 1F, so you can see here it's from 1 to 1F are mandatory. Looks like there are hardly any mandatory here. So the only two mandatory commands here is the inventory command and the stay quiet command, and everything else here starting from 20. In fact, the read block, write block, they're also optional commands. So this is a bit of a surprising. So you might ask, so why the read is not a mandatory? So but there could be a tag which carries only the UID, so there is nothing to read from the tag. Probably that could be the reason why the read command is not a mandatory. Now there are all these commands, they're so simple, they're very straightforward. You got a command to read single block, write single block, lock a block, read multiple blocks, write multiple blocks, select command, this is for the select mode, and reset to ready, and this also we have seen in the transition diagram, and there's a command to do that. So some more optional commands are the right AFI, the application family identifier. See, this is, pardon me, this is an optional command because we know that the AFI may not be present in every tag. So likewise, you can also lock the AFI. You can write the data storage identifier, or you can lock this identifier. You can get the system information. So this command allows you to get the full properties of the tag. So for example, the name of the manufacturer, the size of the memory, the size of the block, the number of blocks, and also you can get the security status. Using this command, you can get the lock status. See here, the security status doesn't have to be just a lock. It is quite possible that some blocks are password protected. So in that case, the security status will have information about whether the block is password protected or not, and also it could be whether it is password protected for the write operation or read operation. So all these things are optional because they depend on the tag manufacturer. So here again, the tag from A0 to DF are called the custom tags. It's an IC manufacturer dependent, and E0 to FF are called as a proprietary tags.